All right, here is chapter 4, problem 23. So this one asks about a projectile that's fired horizontally at some height with some initial velocity. It wants us to find out how long the projectile remains in the air, what distance from the firing point it hits the ground, and also the magnitude of the vertical component of its velocity as it strikes the ground. So to start, I've written down some of the necessary equations that we're going to use. And so for the first part of the problem, how long does the projectile remain in the air? We're going to use this first equation. And looking at it initially, we can kind of simplify it a little bit. Because the projectile was fired horizontally, there's no initial vertical component of the velocity. So we can just cross this term out right here. And then we know the height and we know the acceleration. So we can solve that for the time that it takes the particle or the projectile to fall. So I'm going to write that down like this. Delta y is going to be minus 1/2 gt squared. And let's see. Really, you don't need a minus sign because we're just solving for a time. Time is going to be positive. So we know delta y, and we know g is 9.8. So we can simplify this equation a little bit at first. We can rewrite it like this. And then we're just going to plug in our values. So the time is going to be equal to twice the height. In this scenario, the height was 36 meters over 9.8 meters per second squared. Take the square root of that. And so the time that it takes this thing to fall in this scenario is 2.71 seconds. Okay, so there's the first part. The next part wants us to find the horizontal distance that the particle traveled. And so for that one, we're going to use the second equation written in blue there. And for this one, since we're in the x direction, there's no horizontal acceleration. So what we can do for this one is cross out this whole term right here. And for this part, we're going to write that delta x is simply v naught x times the time. Since we know the initial velocity, we know it's entirely in the horizontal direction, so we don't have to do any cosine stuff. I mean, the angle would just be 0 and the cosine of 0 is 1. So for v naught x, it's just v naught, which for this problem is 380 meters per second. So we're going to write 380 meters per second times the time that we just solved for, 2.71 seconds. And that's going to give us a horizontal distance from the firing point of 1,030 meters. 1,030. So there's that. And then the last part of the problem asks, what is the magnitude of the vertical component of the velocity as the projectile hits the ground? So for that, we're going to use the third blue equation. And we know that because the projectile was fired horizontally, just like how we did for the first part of this problem, we can say that its initial velocity in the y direction is 0. So we can just cross that out. And now all we have to do to find the magnitude of that velocity, the vertical component, is just write Vy is equal to, it's just equal to AT, which is just 9.8 meters per second times meters per second squared times 2.71 seconds. And normally G would be negative, but this wants the magnitude of that vertical component. So we don't have to include the minus sign necessarily. And that right there is just going to give us a velocity at impact in the vertical direction of 26.6 meters per second. So there's that problem. Thankfully, we were able to simplify some kinematic equations there to make the math pretty straightforward. So that was awesome. Hope that helps.